Hello and welcome back. In today's video, we are going to discuss about graphs, and this is our fifth video in the data structure series. Graphs are generally used to solve complex problems, and it has just two components. One is vertex, and the other one is an edge. So all these circles with an alphabet in them is called as vertex, and the line which connects two vertices is called as an edge. So a graph is a collection of these vertices as well as edges, and many things in real life can be represented as a graph. And the most common example is a city map, where the vertices in a graph is represented as a city and the edges in the graph is represented as a route. So when we have two cities A and B, and if there is an edge which is connecting both the cities, then that means you can travel from city A to city B as well as from city B to city A. But in this example, you can notice that there is no direct route from A to C. However, you can travel from A to B and then from B to C. So this is called as a path. These are the basics of a graph. And there are various types of graph. Let's see about few of them. I'm just moving this over to a side. And these types usually come in pairs. So the first set of graphs that we are going to look at are cyclic and acyclic graph. So for this first we need to understand what is a cycle. So a cycle occurs in a graph when there are few vertices that are connected so that it forms a loop in the graph. So to draw an example, if we consider this graph which has four vertices, and let's say these three vertices are connected this way and this vertex is connected to this vertex, then these three vertices together form a loop, and this is called as a cycle. And since this graph has a cycle, this is said to be a cyclic graph. And even the first example which we saw actually has a cycle because all the vertices in this graph are connected to form a cycle. And now draw a simple acyclic graph. If we just remove this edge which is forming a cycle, then it becomes an acyclic graph. I have just removed this edge, then this becomes an acyclic graph because there is no longer a loop in this graph. So this is our first set of type. Moving on, the second set of types that we are going to look at is the directed and undirected graphs. So a graph is said to be directed if its edges are directed, meaning you can travel only from one node or one vertex to the other in the direction in which the edge is pointing to. So to draw a simple example, let's just consider four vertices and say I'm connecting all the four vertices by using edges, but this time I'm adding arrows in order to represent them as directed edge. So an edge with an arrow pointing to one side or the other is called as a directed edge. And if I draw directed edges in the graph, then this means that the graph itself is directed graph. So in this example, I can travel only in this direction, but I can't travel the other way because all the edges are directed. And a graph without these directed edges is called as an undirected graph. So all the other graphs that we have been seeing so far are called as undirected graphs. So this is the second pair of types. And finally, the third pair that we are going to look at, connected and disconnected graph. So a connected graph is where every pair of vertices in the graph, there is a path of one or more edges connecting the vertices. So if we take a graph here, a simple graph, and if we connect all the vertices in the graph, at least with one edge, then this becomes a connected graph. However, if there is one or more vertices which are disconnected, let's say if the graph with four vertex just has two edges, then that means all the vertices in the graph is not connected. This type of graph is called as a disconnected graph. And within connected graph, you have two types, which is strongly connected and weakly connected. And this applies only to directed graphs. So a directed graph is said to be strongly connected if there are bidirectional connections between every pair of vertices. So if there is a graph like this, and if there are bidirectional edges connecting all the vertices, this is said to be a strongly connected graph. Whereas if all the edges are not bidirectional, then it is said to be a weakly connected graph. So this graph is still connected, but then I'm going to draw the edges only in few directions. Then this is said to be a weakly connected graph. And there is a last type that I want to call out, which is called as a complete graph. So a complete graph is a one where all the vertices are connected by edges before every pair. So considering the same four vertices, these are the edges which we were drawing so far. If I connect these two pair of vertices as well, then that ends up connecting the entire graph. So this is nothing but a complete graph where every pair of vertices is connected to each other. So these are the various types of graphs that you will be coming across while solving problems. And it's good to understand them. And whenever you're given with a problem, it's always best to identify the pattern first before solving it so that it'll be easier to start applying the algorithms that you want. Alright, so before closing our session, I want to call out one last thing. The most common operation that is performed in a graph is called as the traversal. So traversing is nothing but traveling through the entire list of vertices by using the edges connecting them. So if I start from the vertex A, then the one way to traverse the entire graph is to go from A to B, B to C, C to D, D to E, E to F, and F to A. Since this is an undirected graph, you can do the same thing starting from A to F and F to E, and so on. So this process of traveling through the entire graph, visiting each vertex at least once, is called as a traversal. And the time complexity involved in graph traversal is O of V plus E, where V is the number of vertices and E is the number of edges. So since we are visiting each vertex and each edge at least once while traversing, the time complexity is considered to be the summation of both the values. So these are the basics of the graph, and it is a very useful data structure when it comes to solving complex problems. So if you have any questions, please leave them in the comments below. See you soon in the next video. Thank you.